with Satvik Tidbits. Now let's continue our discussion of NLM. In the previous video, we learned about momentum, inertia and Newton's first law. Now we are going to continue it with Newton's second law and third law. What is Newton's second law? Newton's second law says that the rate of change of momentum is directly proportional to the force applied. Now let's put it in a formula. Suppose we have a body with mass m moving with initial velocity u, going after a time period t, it changes to final velocity v. What is the change in momentum? So delta p means, this symbol is called delta. Delta p means change in something. This delta means change in something. Delta p means change in momentum. Now, what is this delta p? Delta p is P final minus P initial. Okay. So what is P initial and P final? P initial is mu, because u is initial velocity. And what is P final? P final is mv, because v is final velocity. Now this one, delta P is mv minus mu. Now if we remember, in the previous video we learned about momentum, and momentum is mass into velocity. That's how pi is equals to mu and p is equals to mv. So delta p is mv minus mu. What is rate of change of momentum? Rate of delta p. Rate of delta p is delta p by time period. Rate of something is something by time period. Now, what is delta p by t, which is mv minus mu by time. So, F is directly proportional to mv minus mu by t. Now let us recall second law. What is second law? Second law is the rate of change of momentum is directly proportional to the force applied. So that's how force is directly proportional to change in rate of change of momentum. Now here this mass is common. So F is directly proportional to mv minus u by t. So F equals to, so F is directly proportional to ma. What is A is acceleration, and how did it come? As v minus u by t is acceleration, that's how it came. So F equals to k m a. How did F is equals to, where did k come and where is the directly proportionality sign? This k is a constant, and this directly proportionality sign, to remove any proportionality sign we need to keep a constant, and that constant is k. Now over here the k is 1 Newton. So F equals to F is equals to m a. This is how Newton's second law can be expressed in an equation. Now Newton's second law is done. Let's go to Newton's third law. What is Newton's third law? Newton's third law says that every action has equal and opposite reaction. Let's understand it with this ball. Now, this ball is there. I gave some force. It bounced back. Great. How did it bounce back? How? This is an interesting question in physics. Now, I applied some force to this block, this specific block. I applied some force. So this block applied to How's that possible? Newton's second law says that every action has equal and opposite reaction. Every action, this is an action, has an equal and opposite reaction. This bouncing back is a reaction. Equal and opposite reaction. And points to the note. It is equal in magnitude and in opposite directions and acts on different bodies. Equal in magnitude means easy. I gave 10 Newton, bounce back with 10 Newton. Now opposite directions and acts on different bodies. How? These both are like same. Opposite directions. How? I gave it some force downwards, applied some force, this one got force and went this. So equal and opposite force. That goes like this. In this our case, this is our action and this is our reaction, and this is action-reaction pair. Now, how it is in different bodies? This is one body and this tile is another body. Simple. So when I exert force on this specific tile, then this tile also applies, right? Let's recall what is Newton's third law. Every action has equal and opposite reactions. So this is one force which this wall does work on this specific tile. When action is happened, when reaction is happened, see, this tile is doing work on this one. Initially, this ball did work on this place. Initially, this ball does work on this tile. Now, this tile does work on this ball. Then this must be in different bodies, right? So different bodies and opposite direction. This one here. That means that this is in down. This is in up. This is Newton's third law. Thank you everyone for watching.